Imagine a restaurant where anyone can enter the kitchen and start cooking, which is a security nightmare. Similarly, in Kubernetes, without proper access control, anyone can access and modify resources. This is where Kubernetes RBAC comes in, acting like a bouncer who decides who gets in and what they can do. In this tutorial, we'll build a secure Kubernetes cluster using RBAC, explaining why it matters and how it works. By the end, you'll understand how to control access to your Kubernetes resources. Kubernetes RBAC, or role-based access control, is like a restaurant's access control system. Just as a restaurant has different roles like chefs, waiters, and managers, each with specific permissions, Kubernetes RBAC allows you to define roles for users or service accounts. These roles determine what actions can be performed on cluster resources. The core concept here is to ensure that only authorized entities can access or modify resources, enhancing security and compliance. Roles are like job descriptions, outlining what tasks can be performed, while role bindings are like assigning employees to these roles, determining who gets to do what. Understanding RBAC is crucial for securing your Kubernetes environment and ensuring that your cluster resources are protected from unauthorized access. Let's walk through the Kubernetes RBAC architecture. At the center, we have the API server, which is like the restaurant's front desk, handling all requests. The API server checks with the RBAC authorization module to determine if a request is allowed. The RBAC module consults the roles and role bindings stored in ECT, the cluster's database. Roles define what actions can be taken on which resources, and role bindings map these roles to users or service accounts. For example, a role might allow a user to list pods in a namespace, while a role binding assigns this role to a specific user. Understanding how these components interact is key to implementing effective access control in your Kubernetes cluster. To follow along with this tutorial, you'll need a Kubernetes cluster. You can use a local cluster with Minikube or a cloud-based cluster like GKE. You'll also need kubectl, the command line tool for interacting with your Kubernetes cluster. Kubectl is like the restaurant's intercom system, allowing you to communicate with the staff, your cluster, to place orders, execute commands. Make sure you have these tools installed and are familiar with basic Kubernetes concepts. When deciding how to manage access in your Kubernetes cluster, you might consider using cluster roles and cluster role bindings versus roles and role bindings. Cluster roles and cluster role bindings are like restaurant chain policies, applying across all locations, while roles and role bindings are like individual restaurant policies, applying only to that specific location. Use cluster roles for cluster-wide permissions and roles for namespace-specific permissions. To start controlling access in your Kubernetes cluster, you first need to define what actions can be performed. This is done by creating a role, which is like writing a job description. You specify what verbs, actions, can be applied to which resources. For example, you might create a role that allows a user to get, list, and watch pods in a namespace. This role is then used in a role binding to assign these permissions to a user or service account. After defining what can be done, you need to assign these permissions to someone. This is where role bindings come in, acting like the HR department that assigns employees to roles. You create a role binding that references the role you created and the user or service account you want to assign it to. This effectively gives the user or service account the permissions defined in the role. Let's walk through the process of accessing a Kubernetes resource with RBAC. It starts with a user or service account making a request to the API server. The API server then checks with the RBAC authorization module to see if the request is allowed. If the user has a role binding that grants the necessary permissions, the request is approved, and the action is taken on the resource. If not, the request is denied, ensuring that only authorized access occurs. To verify that your role and role binding are working as expected, you can check the Kubernetes console or use kubectl to describe the role and role binding. Look for the role's verbs and resources, and ensure the role binding is correctly assigning the role to the intended user or service account. This step is crucial for troubleshooting any access issues and ensuring your cluster's security. One common issue with Kubernetes RBAC is misconfigured role bindings, leading to denied access. Another issue is overly permissive roles, which can compromise security. To fix these, review your role and role binding configurations, ensuring they align with your access control requirements. Use tools like kubectl to inspect roles and role bindings, and test access with different users and service accounts to catch any configuration errors. In this tutorial, we've covered the basics of Kubernetes RBAC, including roles and role bindings. We've learned how to create and assign roles to control access to cluster resources, enhancing security and compliance. By understanding and implementing RBAC effectively, you can ensure your Kubernetes cluster is protected and that access is granted only to those who need it. Remember, security is an ongoing process, so continuously review and update your access control configurations as your cluster evolves. Subscribe for daily in-depth DevOps tutorials explained in simple terms.